Hello students, good morning everyone. Yes guys, Balaji, Raya, good morning Nana, good morning. Good morning guys. Welcome back to the physics session. I think still many have not joined. Inform them if they have joined in the Google Meet link. If anyone has joined in the Google Meet link, inform them guys, inform them. Hello students. Yes, okay, good morning everyone. Let us continue now. Let us continue. Yeah. So in the previous session, we have discussed about coefficient of restitution. Before going ahead, let me inform you about this weekend portion. This weekend portion will be one-dimensional elastic collision and one-dimensional collision, elastic and inelastic collision, or elastic and inelastic collision, one-dimensional collision only. Okay, so oblique collision part will not be there for this one. Right. So let us recollect back briefly the concepts we have discussed in the previous session. We have discussed about uh, what are collisions, types of collisions, what is elastic collision, inelastic, perfectly inelastic, and uh, inelastic collision also. Then we have discussed about what is coefficient of restitution, and with the help of this, how can you classify the collisions also discussed. The collision for which coefficient of restitution is equal to 1 is called elastic collision. The collision for which equal to 0 is called perfectly inelastic collision, and the collision which is having the value in between them will be called as partially elastic or partially inelastic. Simply we call it as inelastic collision. Inelastic collision means the collision which is having E less than 1 and greater than 0. Perfectly inelastic means for that E will be 0. So how to define a coefficient of restitution? First of all, how to define coefficient of restitution? Coefficient of restitution, the ratio between the velocities of relative velocities of separation, the ratio between relative velocity of separation and relative velocity of approach is called coefficient of restitution. It is denoted by E. Relative velocity of separation by relative velocity of approach is equal to v2 minus v1 by u1 minus u2. In vector form, if you want to write, you have to write with vector notation, but because while calculating this, these directions of velocity is also important. So you have to keep that also in mind. Now, and also we have discussed about how to find the velocity gained or velocity, hmm? Velocity and the height, the velocity and height of a body dropped freely after nth rebound. Velocity and height of a body, velocity and height of a body, of a freely falling body or a body dropped freely after nth rebound. To understand that, we have considered that the body which you are dropping freely, just before colliding with the ground, you have to consider that as a first body, and the ground you have to consider as the second body. The ground we have to consider as the second body that will be at rest. So before collision, you can consider in just a horizontal fashion like this. And after collision, the body, as the ground will be at rest, it will be treated as a heavy body. So one of the special cases which we have discussed earlier, a small body collides with a heavy body at rest. In that case, we have to apply here. If a small body collides with a heavy body at rest, the heavy body will be at rest only, but the small body will what do you call reverses its motion in the same velocity. That condition we have to apply here. By making use of that, I can express coefficient of restitution here is equal to v1 by v, that is final velocity, by, so I can say that final velocity of the first body by, what is that, initial velocity. If the body is moving initially with velocity u or v, you can write it as v1 by v. So after first rebound, velocity is said to be v1 equal to ev. So v1 is equal to, if you cross multiply e into v. After second rebound, v2 is equal to v into the previous velocity, that is v1. So v1 is equal to ev. By substituting this, we have got this one. Similarly, after nth rebound, we have got vn is equal to e power n v. After nth rebound, vn is equal to e power n v. This relationship you have to remember, guys. And we have also discussed about the height of a body after nth rebound. 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 E is equal to v2 minus v1 by u1 minus u2 is equal to v1 by v, according to this. But if you write this velocities in terms of heights, As v is, if you observe here again in this diagram, v is velocity, the maximum velocity gained by a freely falling body just before the first collision, or first what do you call, before it hits the ground. So it is nothing but root 2gh. From freely falling motion, we have already studied this. It is 2 2gh. Then once it hits the ground, it will raises with a different velocity because it will lose some energy in the collision. It will raises with a different velocity. With that velocity will raises to maximum height and it stops. And again it behaves like a freely falling body. And this freely falling motion, it undergoes a height of h1. So the velocity with which it raises will be equal to the velocity with which it hits the ground after coming back from the maximum height position. So we can take it as v1 is equal to root 2 gh1. So by making use of this, here you can say v1 is root 2 gh1 and v is root 2 gh. And simplifying this, you can write root square root of h1 by h. Square root of h1 by h. And squaring both sides, you can write e square is equal to h1 by h. E square is equal to h1 by h. And simplifying this further, you can write h1 height raised after first collision is equal to e square h. E square h. After second collision, e power 4h. After third collision, e power 6h. That means the power is increasing every time to the two multiples. So you can write it as height raised after nth collision will be e power 2nh. E power 2nh. I hope you remember these relations. So note down these points once again. Just the brief points. Then let us go ahead. Let us go ahead with the questions. Right. Let us work out one question here. Level 2. Level 2 exercise 1. Page number 47. Page number 47. See here, guys. Question number 45. Based on coefficient of restitution. Question number 45. Page number 47. Page number 47. So what is given here? It is given that a tennis ball bounces down a flight of states. Bounces down a flight of states. States means steps. Striking each step in turn and rebounding to half of the height of the step. Half of the height of the step. Rebounding to half of the height of the step. The height of the coefficient of restitution is. The coefficient of restitution is. So what is given here and what you are asked to find? What is given here and what you are asked to find? So question number 45. So it is given that a tennis ball bounces down a flight of states. Flight of states means just steps, like you can say in your house or in a building. If you see the steps are downward steps, not upward, downward steps by standing on the height point. If you drop a ball, it is observed that it is bouncing every time, but it is rebounding to half of the height of the step. That means in every time it is reducing the bouncing height to half. So especially the first case if you consider, as we know that and you are asked to find coefficient of restitution. So if you say h1 is equal to h, so first h usually if it is bouncing first from height h, if we take it as this itself is h1. If it is h, then after the second bound, after the first collision, you can see this bounce. If it is h2, which is equal to half of it, h by 2. h2 is equal to h by 2. Provided here during this collision, if coefficient of restitution is e, then what is e you are asked to find? We have to say that e is equal to, in terms of h already I have calculated that, right? h1 if it is in terms of, if this is h and h1, then h1 by h. If it is h1 and h2, then you can write it as h2 by h1. So h2 is under root, right? Under root. This also have to be careful about. Is V equal to relative velocity of separation by relative velocity of approach. So we'll get under root. So it is equal to square root of h2 will be h by 2. Yes, h2 will be what? H by 2 and h1 will be h. On simplifying this, h gets cancelled, we'll get 1 by root 2. So E will be equal to 1 by root 2. Note on this quickly. Right, next. Question number 46. Let us see here only. Question number 46. Right. Next, let us see question number 46. What is given here is a ball hits in the question number 46. It is given that a ball hits the ground and loses 20% of its momentum Coefficient of restitution is what is given here. A ball hits ground and loses 20% of its momentum, means it is a percentage change or percentage loss of momentum delta p by p into 100 or whatever, just you can say that okay, p into 100 is equal to 20%. This way you can say that. Otherwise simply you can just use simple logic that it loses 20% of its momentum. Then coefficient of restitution is. Then what should be the coefficient of restitution is the question point here. So let us say initial momentum is P. Final momentum should be when it loses 20% of the momentum. 20% of the momentum. Final momentum should be, if it is 100 P, then final momentum, if initial momentum, if you take it as 100 P, it will be, after losing 20%, it will be 80 P. Whereas if you take initial momentum is, if you take initial momentum is P1 is equal to P, then P2 should be 0.8 P. 0.8 P. So this is how you have to understand this. So we can say what is coefficient of restitution by using this. Can you find, coefficient of restitution is relative velocity of separation. Relative velocity of separation by relative velocity of approach. By relative velocity of approach. This is equal to, so if you multiply both sides, numerator and denominator with mass into velocity will give you momentum. So you can say relative momentum of separation. So when the separation comes here, in case of a freely falling body bouncing, when it comes and hits it, When it is during the hitting, you can call it as approach. After hitting it, bouncing up. So you can say it is a relative momentum of bounce. Relative momentum of bounce. That is how you can take it, right? So can also call it as rebound momentum. Relative momentum of separation. During separation, relative momentum during separation, that is during bouncing. But relative momentum during approach or during striking. So you can take you can consider this as by multiplying both numerator with and denominator with mass. You can express this in terms of rebound momentum by rebound momentum by striking momentum, striking or hitting momentum, striking momentum. So when it is striking, let us, if you consider the initial momentum is P1 is equal to P, if the striking momentum is, if the striking momentum is P, then rebound momentum should be 0.8 P. 0.8 P, according to this, P2 will be 0.8 P. So PP gets cancelled. So E will be equal to 0.8. So this is how we get this one. Or if you take it as 80p, 100p, then also you get the same 0.8 only. So 8 by 10 will get, so that gives you 0.8. This is how you have to calculate this. Next. Next question. Let's see here, guys. Question number 46 or then 47. Question number 47 is given that a plastic ball falling from height 4.9 meter rebounds number of times. If total time for second collision is 2.4 seconds, then coefficient of restitution is. So here, to understand this, we have to again get into that what you call the collision coefficient of restitution case, and we have to understand how to express coefficient of restitution, how to express coefficient of restitution in relation with the time, in relation with time. So relation between height and coefficient of restitution we have discussed, and velocity and coefficient of restitution we have discussed. What is that? Height raised after nth rebound and velocity after nth rebound in terms of yield. So what about the time taken by the ball? What about the time taken by the ball during the what you can call it as during the bouncings? Or you can say if you drop a ball, it will fall and it will bounce up. Then again it is going to fall and bounce up. A number of times it will bounces. After some time it will stop. So you may say, well, how much time it may take for the ball to stop bouncing? Let us try to understand how to find this. So now write down the subheading. Write down the subheading. Write down the subheading. To find to find to find time taken by the ball, to find the time taken by the ball, to find the time taken by the ball to stop bouncing, to stop bouncing, to find the time taken by the ball to stop bouncing. How much time it takes? How much time it takes? Yes, guys. To understand this, again, let us try to look into this scenario. If a ball of mass m is released from height h from rest, okay, and it travels height h to reach the ground. Let us say it has taken time t seconds to reach the ground after traveling height h. Then what will be the time taken by the ball to reach the ground from the freely falling motion? Again, you have to find this. Okay, if we know that time taken is equal to from the equations of motion only, you can observe that uh, T is equal to root 2h by g. T is equal to root 2h by g. You can say T is equal to root 2h by g will be the time taken. How? During freely falling motion. I have discussed if you know the if you want to find the velocity by knowing h, v is equal to square root of 2gh. Otherwise, if you know velocity and to find the distance traveled or height traveled, you can write it as h is equal to v square by 2g, right? And by using the equations of motion as v equal to u plus gt, so we can take it as u is 0, and on simplifying this we will get this one 2h by g. Okay, so then you can also write our so depending on if you want the distance h, s is equal to ut plus half at square. If ut plus half at square, if you relation by using, you can get this one, not equal to u plus gt. The final velocity can in terms of velocity you will get it at time, but in terms of height, if you want, you have to use s is equal to ut plus half at square. Let me give you that also how to get this, as by using the equation s is equal to ut plus half at square. If the ball is dropping the ball with initial velocity 0, then u will be 0, this term will become 0, and a will be minus g, and s is it's traveling down, so s also is minus h, so you can write it as minus and minus gets cancelled. From this you can write h is equal to half g t square. On simplifying this, you can write 2h by g is equal to t square, or t is equal to square root of 2h by g. So this is how you will get t equal to this. So to fall to this height, it will get time t equal to root 2 h by g. After first collision, first bounce, let us say it bounces to height h1, and again it behaves as a freely falling motion and comes down. So this is next, before second collision it will travel h1 plus h1 to h1 distance. So for how much distance time it takes for traveling this height, the same time it will take to travel this distance vertically down under gravity. So you can take this is first collision. After first collision, it raises to this. Before second collision, it takes 2t. If you say the time taken for this is t1, 2t1 time it will take. 2t1 time it will take. So like this, in the next collision, if you consider, if it is taking time t3 to raise to a height yeah, t2, let us say t2 time to raise to a height as h2, then it takes time t2 to go up, then again t2 to come down. So before this collision it takes 2t2 time. So likewise, before stopping it takes a total time. If you take a t total is equal to time before time taken before first collision is t, then before second collision 2t1 plus before third collision 2t2, like this it will take plus so on up to the infinite number of bounces it will undergo. Okay, so on substituting these terms t1 t2 and in terms of heights, you can write it as t can be expressed as square root of 2h by g plus 2 into t1 will be square root of as 2h1 by g, 2h1 by g plus 2 into square root of 2h2 by g, h2 by g plus so on. I have to consider here. Here, if you observe, again, if you substitute for h1, h2, h2, h2 and so on, already you have calculated those. What is the relation between h1 and h? What is the relation between h1 and h? You have to take it. You will get here. This is equal to square root of 2h by g plus 2 into plus so on. You will get. So here if you 2h by g and 2h by g, 2h by g if you take out, you can write it as, simply you can write this first term as it is, square root of 2h by g plus this term here, this 2 anyway cannot bring it because it is root. So otherwise 2h by g will be common in every term. In every term, if you bring this out again by taking e, it is e square here. If you take e out, it becomes e. Here in this e power 4, let us bring only e and keep e square here only. Then you can write in every term if you bring out to e square, and here 2 will be there in every term and e also will come out in every term, and these terms you can write it as 2e into square root of again 2h square root of 2h by g common here, because e have taken out and this if you take out, this 1 will remain here, plus here if you bring this 2h by g under root and 2 1 e square out, 1 e square will be there under root, 1 e square will be there. So you can write down this as what is that, 1 plus that e square can be taken as e plus so on like this. In the next one you get e power 4, that you can take it as e square. So like this if you write, you get one series here, infinite series, 1 plus e square plus so on. This will be in an infinite series. We can call it as infinite series, infinite sum series, sum of infinite series. So if you remember sum of infinite series, here I will give at the side, sum of infinite series is equal to a plus ar plus ar square plus so on up to infinity. If you are having, if a where a is a first term and r is common ratio, it is this by this r, this by this r will be called as common ratio, then sum of this infinite series, you have to remember this guys. Not only here, you will use this formula in different chapters and while dealing with the different concepts. Sum of infinite series can be expressed as first term by 1 minus r, where r is common ratio. Okay, so this if you substitute it here, this in this form, you can write this as square root of 2h by, here root 2h by g, root 2h by g is there. Again you bring this out, root 2h by g out. Now you will get here 1 will be there, 1 plus 2e will be here. So this simplification you have to do little carefully guys. 2e into, only this part can be expressed as first term by 1 minus e. First term is 1 here, so 1 by 1 minus common ratio will be, so e by 1 e square by e is e, so it will be 1 minus e. This will be this term. So sum of the infinite terms will give you this. This on simplifying further, we will get to square root of 2h by g into 1 plus, this is 2e into this means 2e by this, 2e by 1 minus e. On cross multiplying and simplifying, this becomes 1 plus e minus 2e. Then what you will get? Then what you will get? This can be further expressed as square root of 2h by g into square into 1 plus e minus 1 minus e plus e, 2e will give you e. 1 plus 1 minus e plus 2e by 1 minus e. So minus e plus 2e becomes plus e. So 1 plus e by 1 minus e will get. So this will be the total time taken. T is equal to square root of 2h by g into 1 plus e by 1 minus e. This will be the total time taken by the body to stop bouncing. To stop bouncing. Note down this everyone. Note it down quickly. Here itself I would like to discuss one more point. Then we will do the numericals related based on this. How to find the total distance traveled by the ball before it stops bouncing? The total time taken by the ball before it stops is this. Then how to find the total distance travel? So again in this diagram, if you see the distance travel is nothing but height in the before this first collision h. Before the second collision is it bounces up through height h1. Then again to travel h1 before the second collision. So 2h1 it travel. Next after. So after second bounce, it will travel to height h2, then again h2 down before the next collision. So like this, h plus 2h1 plus 2h2 and so on distances it will travel before it stops. So what will be that total distance traveled? Let's try to find out now. So write down next subheading. The diagram figure is same, common for all this. And you have to understand all these scenarios from the diagram. So write down next subheading. To find total distance traveled, to find to find the total to find the total distance traveled by the ball before it stops bouncing, by the ball before it stops bouncing. To find the total distance traveled by the ball before it stops bouncing, is how much? To understand this, let us again consider the same diagram. So let us say this is the ground. A ball is the diagram you have to be well aware of, guys. It is falling from height h. Initial velocity is 0. Okay. Then after first bounce, this is first bounce. After first bounce, it raises up with velocity v1. Okay, here the velocity will be v, so it raises up with velocity v1. It raises to some height and h1. It raises to height h1, right? And in time t1, then again comes back with initial velocity 0 here. So it travels to h1 distance, and this is after first bounce. Then it after coming back it undergoes second collision. After second collision, it undergoes second bounce with velocity v2, and it goes to a height, let us say h2. Then again it travels back to the same distance h2. So and it undergoes a third collision or third bounce. Like this it undergoes number of collisions. So before and after some so many collisions, infinite bounces, it stops bouncing. So let us say the total height, the total height is, let us use the symbol, any symbol h or d or whatever it is. The total distance traveled, let us say not total height, total distance traveled. Total distance, we have used the word total distance traveled. So this implies total distance traveled. Total distance traveled is d. Let us say it is d. D is equal to distance traveled before first bounce is h. After first bounce h1 plus h1 to h1, plus after second bounce h2 plus h2 to h2 plus so on up to infinite bounces. It will travel the distances before it stops. We can't say it will undergo 10 bounces or 100 bounces or 1000 bounces. Infinite. Whatever the small bounces it may undergo. So if you consider this again, and if you replace this values, h values with in terms of e, you can write this as this is equal to h plus 2 into h1 in terms of h is e square h. Already we have discussed this, right? If you want, you can recollect back from here again. As here this as just like as we have substituted here h from this, yeah, where here h1 is equal to e square h and h2 is equal to e square h1 and hence it is equal to e power 4h. Likewise, if you make use of those relations, then you'll get 2 into it is e square h plus it is 2 into h2 is e square h1 and again h1 is e square h2, so it will be e power 4h plus so on unit. So this I am again simplifying by taking In this here 2 here in every term again you will get here 2 into h3 will be e power 6 h plus so on will get right. 2h is common in every term and e square is there in every term also e square will be there. So in all the from here onwards in every term if you take is 2 e square h common, then you can write like this h plus 2 e square h into this will become 1 plus 2 h is out 1 e square comes out means another e square will be there. You can write it as e square plus 1 e square comes out means here e power 4 will be there. E power 4 will be there. So plus so on will get up to infinity. Sum of the infinite terms. This also represents sum of the infinite terms. So again you take here if we have infinite terms, sum of infinite terms with first term is a plus next a r plus a r square plus so on, then some of these infinite terms can be expressed as first term by 1 minus common ratio. Here R can be called as common ratio. So by making use of this relation, here you can write this again as h plus 2 e square h into here it is first term is 1. First term is 1. So 1 divided by 1 minus common ratio is e square by 1 is e square. E power 4 by e square is e square. So it will be e square. Common ratio will be e square. So this further you can also express it as this is equal to h. Here again if you take this h is only h is common in these two terms. If you take h out, you can write 1 plus 2 e square by this. 2 e square by 1 minus e square. This we simplify further by cross multiplying here. By cross multiplying here, 1 plus 1 minus e square plus 2 e square, and if you simplify this further, you will get this is equal to h into 1 minus 1 minus e square plus 2 e square divided by 1 minus e square. This on simplifying 1 minus e square plus 2 e square gives you 1 e square goes means it will be 1 e square remains 1 plus e square. So h into 1 plus e square divided by 1 minus e square will remain. So this gives you the total distance traveled. Therefore, total distance traveled before it stops is d is equal to h into 1 plus e square by 1 minus e square. This is how you have to simplify this, guys. Note down this everyone quickly. I hope you have copied, guys, this one. Right. So let us see the question number 47 now. A plastic ball falling from height 4.9 meters rebounds a number of times. If total time for second collision, you can see here the time related thing. This is first collision, second collision. If total time if total time for second collision is 2.4 seconds for second collision to happen means it comes and collide first, bounce up, then collides. Just you are not supposed to consider the bouncing here after this. Till here only means the distance traveled will be this plus h1 plus h1 only. That only have to consider. Okay. So and time also time taken to travel here, then up, then down. Here only till second collision means. So if total time for second collision is 2.4 seconds, means to travel here, then go up, then come down. That is 2.4 seconds. Then coefficient of restitution is. So how to find coefficient of restitution by considering this time is the question. So we know that total time is here t plus 2 t1. So see here, write down this question number 47. Question number 47. Page number also 47. So total time T total is equal to time taken for first collision plus before second collision is 2T1. 2T1. This is equal to 2.4 seconds. 2.4 seconds. And a ball falling from a height of 4.9 meters. The initial height is, you can say this is h is equal to 4.9 meters initial height, right? So if here, what is the question then coefficient of restitution is, so here you have to use the relation. This is t is equal to, only for two collisions. How can you take in this t in terms of h? You can take, how can you express that? T in terms of h, t is equal to square root of 2h by g, 2h by g. Okay, then plus 2 into t1 can be expressed as t1. How can you express t1? So use this same relation. T1 is equal to what? Here, T1 is equal to 2h1 by g. H1 is e square h. E square h. So if you simplify that by substituting this, and if you simplify, what you will get? So you will get 2 e square h by g under root. 2 e square h by g under root. 2 into 2 e square h by g under root e square h. So here, if 2h by g only, if you take out 2h by g under root, if you take common, we will get 1 plus e square will become e, so it becomes 2e. This is equal to total time. Here h is given, t is given, g is known. Substitute these values and find out e. So you can write 1 plus 2e is equal to t by square root of 2h by g. So this is 1 plus 2e. Then this further you can also write it as 2e is equal to t by square root of 2h by g. 2h by g. This entire thing minus 1 is 2e. E is equal to this entire thing divided by 2. So find out just on simplification. Substitute the values and calculate that. On simplification we get 0.7. So this will be, this implies on simplifying we will get E is equal to 0.7 you will get. Okay, substitute and find out this. Okay, as time up, I am winding the session now. Take care everyone, bye bye.